Hello, and welcome to the processing of black and white film. To understand the processing of black and white film, you should first understand what film is made of. Film is made of 5 layers: the overcoating, emulsion, base, antillation backing, and non-curl coating. The overcoating layer is a clear gelatin that protects film from friction, scratches, and abrasion prior to development. Emulsion is the most important layer. It's made of gelatin that suspends silver halide crystals, and it's where the image is formed. The next layer is the base, which is most commonly composed of cellulose acetate. Its sole duty is to support the emulsion. The antillation backing is a dark layer at the bottom of the film. It's most commonly made of remjet, which is carbon black and a water-soluble binder. Without the antillation layer, the light projected through the emulsion will bounce off the base, creating a second hazy image. The antillation layer absorbs those extra photons, making a crisper image. Lastly is the non-curl coating. Emulsion swells when wet and shrinks when dry, causing the film to curl during processing. This layer is a hardened gelatin that helps film keep its shape. Now let's go back to the emulsion, with its gelatin and silver halides, most commonly silver chloride or silver bromide. Let's look at silver bromide. Its formula is AgBr, where silver has a +1 charge and bromine has a -1 charge. The bromine ion is bigger than the silver ion. Now let's look at silver bromide crystals. Theoretically, a crystal is a perfect lattice, but in the real world, crystals contain natural imperfections, which are crucial to photography. Now that we know what film is, we need to understand the latent image. The latent image is the initial image formed on film when the camera shutter opens, allowing light to reach the film for the first time. On a molecular level, a single photon is hitting a silver bromide formula unit, knocking out one of bromine's electrons. The electron roams the crystal until it gets stuck in an imperfection. Eventually, many electrons get stuck here, creating a strong field of negative energy. This attracts silver ions not well set in the crystal, creating a bunch of metallic silver. This cluster of silver is called a development seed. Because development seeds are so small, film before and after exposure to light doesn't look any different to the naked eye. If we could see the development seeds, it would look something like this. So, how do we see the images formed by development seeds? The developing process. Step 1 is developer, which is made of a solvent, developing agents, an activator, a preservative, and a restrainer. Water makes the whole thing a solution. Hydroquinone augments the developing seeds, making them visible to the naked eye. Sodium hydroxide creates the developing agent's preferred pH. Sodium sulfite preserves the solution. Potassium bromide prevents developer from augmenting unexposed crystals. Step 2 is the stop bath, which is a solvent and an acid, commonly water and acetic acid. Because developer is a basic solution, and the next step, fix, is an acidic solution, stop bath is necessary to make any basic solution left on the film acidic. Step 3 is fix, which is made of sodium thiosulfate, solvent, an acid, a preserver, a hardener, and a buffer. Sodium thiosulfate, or hypo, dissolves unexposed silver halide crystals. Water makes the whole thing a solution. Acetic acid serves the same purpose it did in the stop bath. Sodium sulfite preserves the solution. Potassium alum hardens the emulsion after becoming soft and developer. Boric acid keeps the solution at a constant pH. Step 4 is the wash, which is just water. It washes away any remaining chemicals or unexposed silver halide crystals. Once processed, you can see the image on your film and invert the image onto photo paper in a darkroom to look something like this. Thanks for watching!